What do diamonds, salt, gold, and rocks have in common? They are made of minerals. Minerals are all around us, and we use them in making houses, roads, computers, paints, and hundreds of other things. We even eat them. So, what exactly are minerals? Minerals are naturally formed, non-living, solid chemical substances. If a solid substance is not from a plant or animal, or made by humans, then it is probably made of minerals. Minerals are in the rocks of Earth's crust and come in thousands of varieties. Valuable minerals are not evenly distributed around the world. Long ago, Earth was a giant ball of hot mineral soup called magma. Over time, the surface of the magma cooled to form a hard rock crust. We live on this crust, and the rocks around us are part of it. We find concentrations or deposits of certain minerals here and others there because the minerals in magma were not thoroughly mixed. In addition, billions of years of change to Earth's surface has rearranged minerals even more. Geologists must constantly look for ones we need, like gypsum and diamond, phosphate and copper. Sometimes we find deposits of mostly pure mineral. For example, this rock is made entirely of graphite, the material that used to be used in pencils. More often, the mineral we want is aggregated or collected together with others in rock. Rock, after all, is just a hard portion of Earth's mineral soup. In this piece of granite, we see at least 3 kinds of minerals, one white, one black, and one light gray. Although these minerals are together in rock, they remain separate minerals. That is, quartz in this rock is still quartz, no matter what its neighbor is. Minerals like gold and silver aggregated in rocks can sometimes be separated out by processing. Identifying minerals is challenging because there are so many kinds. Geologists try to figure out what they have by testing physical properties. Physical properties include such things as color, hardness, luster, density, and other features that make a mineral look the way it looks and do the things it does. Color is an easy place to start. Sulfur is yellow and azurite blue. But color is usually not enough. Quartz, Earth's most common mineral, can be many colors. However, quartz is harder than most minerals. It resists scratching even with a knife. Geologists can compare any mineral's hardness to Mohs scale. Mohs scale ranks 10 common minerals from the softest, talc, to the hardest, diamond. Another physical property, luster, refers to the way a mineral reflects light. Some minerals have dull surfaces, others shiny. Density is determined by how heavy a mineral is. These two minerals seem to be the same until you feel their weight. Minerals may also be tested for magnetism, the color of streaks they leave on a rough surface, and even the way they break apart or cleave. Mica, for example, cleaves into thin layers like sheets of paper in a stack. When hit with a rock hammer, calcite cleaves neatly into slanted boxes. Fluorite cleaves into this remarkable shape. Testing each physical property, such as cleavage, hardness, and color, takes the geologist one step closer to identification. Geologists continue testing physical properties until a mineral is identified. Minerals are made of elements. Elements are Earth's basic building blocks. An element cannot be divided into other substances. However, elements can be chemically put together to form new substances. Earth has only about 100 different elements. Included are hydrogen, oxygen, silicon, carbon, and iron, to name a few. Most minerals are made of two or more elements chemically joined together. When elements join chemically, they may produce something that seems quite different from the parts. For example, the elements silicon and oxygen together make quartz. We breathe oxygen as a gas, but in chemical combination with silicon, it produces a very hard rock. The element chlorine by itself is poisonous. Combined with sodium, it becomes everyday table salt. Earth's 100 building block elements mix chemically in thousands of ways to make thousands of different minerals. Minerals grow to increase in size. Most minerals grow in liquid, such as water or magma. Here they add bit after bit in an orderly fashion. For example, the elements sodium and chlorine of table salt together form a cube. The cube is repeated throughout a piece of salt, no matter how big it grows. Other minerals have different shapes, including some complicated ones. But whatever the shape, it is repeated in orderly fashion throughout the mineral. Under the right conditions, a mineral may grow quite large and into a special shape called the crystal form. Each mineral has its own crystal form. We often call large pieces of minerals with good crystal form simply crystals. Crystals are the flowers of the mineral world. Crystals like these are rare because our world is so rich with minerals, few have room to grow very large. Thousands of kinds of minerals occur on Earth. We identify them by testing physical properties such as hardness and luster. Minerals are made of elements, which form repeating patterns throughout the mineral. Sometimes minerals grow into large crystals. More often, two or more kinds of minerals crowd together in rock. Glamorous gems, useful metals, and edible table salt are just a few of the many important naturally formed, non-living, solid chemical substances we call minerals. To help you review information in this program, please answer the following questions. Good luck, and let's begin. 1. True or false? Minerals are evenly distributed around the world. 2. True or false? Rocks may be made of two or more minerals. 3. True or false? Physical properties of minerals include color, hardness, and cleavage. 4. True or false? Most minerals are made of two or more elements. 5. True or false? Minerals grow in an orderly, repeating pattern.